Today we'll discuss about JEE Men's 2016 paper physics. Next question is question number 9. The question is again it is about the thermodynamic process, heat and thermodynamics chapter. N moles of an ideal gas undergo a process A to B like this are shown in figure. The maximum temperature of the gas during the process will be. So when the process starts from here and then goes to the point B, then during this process, at which point the temperature of the gas is maximum temperature, this you have to find. So that means you have to go for maxima minima. So first you write the equation of T in terms of say V or P. Then we have to take the first derivative of that and equate it to 0 to get at which point of T, what value of T the temperature is. Then we put that value in the general equation that we are going to find. So let us proceed. Because you know the coordinate and it is a straight line, and I know the coordinate of these 2 points. If I know the point, then I can get the equation of this line, equation of a straight line using 2-point system. So 2-point system, equation of a straight line. Then I will go for calculations. So first of all, the path here and here, this point A has the coordinate. You can see here this is your x coordinate V0, the y coordinate is 2P0. Similarly here the B point is having x coordinate 2V0 and the y coordinate value is P0. In general, if we have point like A and B and we have equations like the coordinates are x1 and y1, here the coordinates are x2 and y2, then I can write the equation of this line. The equation of this line is y minus y1 equals to m into x minus x1. Y minus y1 equals to m is y2 minus y1 divided by x2 minus x1 into x minus x1. This is basically what I've done. This is the slope and this is the slope. So just this is a point formula for equation of a line. So here I will just use this concept here. This is my x1, this is my y1, this is my x2, and this is y2. So I'll write in this line in place of y I'll write p, in place of y I'll write p, and in place of x I'll write v because v is in x-axis. So first I'll write this, then I'll substitute y as p, or I'll put y here. So this is p minus y1 is this value, equals to y2 minus y1 means this minus this, y2 minus y1, that is p0 minus 2p0 divided by x2 minus x1, that is 2v0 minus v0 into x minus x1, x is your v minus x1 is your v0. This is the equation that I can write for this process. Now I have to solve this, simplify this and then proceed. The equation was p minus 2p0 equals to P naught minus 2 P naught, that is minus P naught, divided by 2 V naught minus V naught is V naught, and this is V minus V naught. Okay. Now I will separate the equations. So P minus 2 P naught equals to minus P naught by V naught into V plus P naught by V naught into V naught. What I'm doing is this part is taken inside, so this becomes positive and this becomes negative, with this factor multiplied with the corresponding terms. So I'll just cancel out these two, and this is the, I write that I also know that y equals to mx plus c. This is the equation of a straight line. In my y direction I have got pressure, and in my x direction I have got volume. So I write P as, this is brought to the other side of the equation. This is 2P naught minus plus P naught here, plus P naught and minus of P naught by V naught into V. This is V is your x, this is like your x, and this is like your y. This is y. So this y P equals to, this is 3P naught, and this is minus P naught by V naught into V plus 3P naught. If I compare this, this is my y, this is like m, obviously negative slope, and this is your x, and this stands for c, y is mx plus c. Now the question is to find the maximum temperature of the gas during the process is. So during this process the pressure is maximum. For maximum or minimum of this temperature, so we have to find the temperature because this is in pressure. So this is in pressure form. I have to write in, to bring in temperature from one equation that I already know for ideal gas, that PV equals to nRT. If I use PV equals to nRT, then I have only P, so I'll multiply V throughout the equation. This equation becomes PV equals to minus P naught by V naught. This is V square plus 3P naught into V. This PV becomes nRT, so I'll substitute here nRT equals to minus P naught by V naught, V square plus 3P naught V. I want T to be maximum, so first of all I'll write what is T. T equals to nR factor is divided in this side, so I'll rewrite that. So this becomes, T becomes 1 upon nR, nR is divided here, and the factor what was earlier there will remain as it is. So 3P naught V. Now for T, that this temperature to be maximum, I have to differentiate this with respect to V. V is the variable here. Maximum dt over dV should be equals to 0. This would be 0. So for this condition to apply, I have to differentiate this equation with respect to V. So differentiate equation, this equation say 1 with respect to volume. If I differentiate that with respect to volume, then this is dt over dV, differentiation of this side. 1 by nR is a constant, and if I differentiate this equation inside, with respect to V, this is 2V. So this is minus P naught by V naught is a constant, it will remain as it is, and differentiation of V square is 2V, plus differentiation of this is 3 P naught, V differentiation is 1. So so this is a differentiation, and I'll make this to 0. If I make this to 0, because I have to find the maximum temperature, so this has to be 0. So making this 0, I have this part equals to 0, because that will multiply here and become 0. So minus P naught V naught 2V plus 3P naught becomes 0. So from here I like that this goes to that side, it becomes positive, so both sides are positive. So I'll write P naught by V naught to V equals to 3P naught. So from here that P naught will also cancel out, and from here I'll get V equals to 3 V naught by 2. That means for this value of V here, this T becomes maximum. So if I make it 0, then I get the condition for maxima or minima. So if I put this value here, I'll get T becomes maximum, and let us see what I'm getting. If I put that value of V equals to 3 V naught divided by 2 in equation number 1, what I will get? T maximum, that will become maximum now, equals to 1 upon NR minus P naught by V naught V square. So this becomes V square, means this is 9 V naught square divided by 4. So you can see here, this is minus P naught V naught by V square. So V square is 9 V naught square by 4 plus 3 P naught V plus 3 P naught V. V is again 3 V naught divided by 2. If I solve this, then it is 1 upon NR. This is V naught cancels, so it is 9 by 4 P naught V naught plus 9 by 2 here P naught V naught. If I solve this, then it is 2 multiply here, 2 multiply there, then 4, this is 18. 18 minus 9, that is 9. So it is 9 P naught V naught divided by 4 and 1 upon NR. If I multiply 2 here, it becomes 4, so LCM is 4, and 2 multiplying here 18, 18 minus 9, so minus I have already taken is 9, so it is this value. And if I see the options, then it is I'll rearrange this 9 upon 4 P naught V naught by NR. This is the maximum temperature. If I see the option, you can see the option here, 9 P naught V naught divided by 4 NR, 9 P naught V naught by 4 NR. So this option number 1 is the correct option. Again, there is another shortcut method you can use, just for the sake of curiosity. I'll just tell you that this is the maximum at midpoint of this. At midpoint, the temperature is maximum of this line. So how to find that midpoint? If you can find that midpoint, then at that the temperature is, and what is the midpoint value? I have to know that this value plus this value divided by 2. Okay, so 2 v naught plus v naught, 2 v naught plus v naught divided by 2 is 3 v naught by 2. And if I tell you here 3 v naught by 2, after so many calculations, so you got 3 v naught by 2. Here in one step you get 3 v naught by 2. So if you have this idea that here at this midpoint the temperature is maximum, if you know that, then that is helpful. If you don't know, you have to go solve this total thing. So once I know this, the point where this is the value of v, this is the value of v, that is 3 v naught by 2, this coordinate is 3 v naught by 2, that is 1.5 v naught. So at this value of v, I have got this maximum temperature because maximum, so I can use that directly in the equation to get the answer. That way also you can do. So by doing that, you will avoid you don't have to calculate this and save time. Okay, anyway, the option number 1 is correct. Thank you very much.